Hello, everyone, and welcome. Today's seminar is on soybean gall midge. This is one of the installments for Crop Protection Network. And just go through a few of the quick, let's see if I get this to start. There we go. Crop Protection Network brings this seminar series to you free of charge today, and there is one more in 2 weeks. A few key things to go through before we begin. With our speaker is that if you have technical issues, please reach out to my colleague Lacey. Her phone number is 608-268-4953. This is a quick webinar. It is scheduled for 30 minutes. It is thus half a credit for pest management. Please submit any questions you have in the question portal, and we will address them at the end of the webinar time. The webinar is being recorded, and it will be available to you within about a week after today's date. And again, I said that there is one more installment in the Crop Protection Network series, and that is in 2 weeks on March 3rd. Our speaker today is Justin McMechan. He is speaking to us today from University of Nebraska-Lincoln. He has his graduate work in University of Minnesota and also Nebraska-Lincoln. And in addition to soybean gall midge, he also works with other arthropods, corn ear development, and hail damage. And this work is part of a larger effort to understand arthropods across the United States. All right, Justin, I see you, and I'll send the slides over to you.
All right, well, thank you for the opportunity. Is it coming up okay? I see my presentation. There we go. So again, thank you to the American Society of Agronomy for allowing me to present on this topic and the Crop Protection Network. I'm going to cover a lot of things today, and there's a lot of information on this insect because it's new to our system. It's a new species in the system. But my goal today is to provide the foundation for risk and understanding of risk. And then to bridge to this road to management, which is not an easy one that you're going to find as we go through the course of this presentation. And so with that, a few things that'll be on this front slide that you can see, which is the amount of injury along the edge of the field. So this insect's an edge infesting insect. And then on the other side is the orange larvae that are pretty characteristic of this insect for its identification. We'll touch on both of these in a lot more detail. So to begin, soybean gall midge is a new species. That doesn't mean new to the U.S. It means new to science. And so it was given the name Resilia maxima maxima meaning its presence on soybean, as well as the amount of potential injury that this insect can cause in soybean. And that identification occurred as a result of adults being collected in 2018 from the research station where I work, the Eastern Nebraska Research and Extension Center. And then those adults combined with some genetics work and their morphology led to the formal description of the species in 2019. And if you're wondering, like, how unusual is this that new insects like this show up in our system, it's pretty unique. Raspberry cane midge is one that's pretty closely related to soybean gall midge. It's in at least the same genus, and it attacks raspberry. And it emerged as a pest in the 1920s, so 100 years ago, which is quite a while. There's been a lot of new identifications in this genus. But the two insects, one 100 years old in the system and another one, really recent, shared a similar emergence into the system in that both of them showed up, suddenly within a year or so, or a couple years. And unfortunately for raspberry cane midge, it's still a significant pest today, even 100 years later. And so that should give you an idea of just the amount of challenges and the fact that this thing is going to be around for a while. Two things to point out between these two insects is how similar they are and how they infest the plant. So a soybean plant with the fissures or cracks that are written on it, those fissures or cracks, as you find throughout this talk, is going to be really important to the infestation. And then like that, raspberry cane midge has these natural fissures or cracks that appear on the primocanes, and it's important to that insect's identification. So the two have considerable overlap in their understanding, and we've been using that insect to understand this system. So as we start this conversation about the difference and where this insect is located, I want to start by talking about the distribution of this insect. Where is it in our landscape? And so this is 5 states within the Midwest of the United States, and the colors represent the areas where we found this insect over the last couple years. And one thing I don't want you to take away from this image is that soybean gall midge is necessarily spreading with each one of these years. What I really want you to understand is that this is its current distribution, and that we're getting very good at finding this. The more we learn about its biology and ecology, and you'll see that over the course of the talk, the more we can find it in really low numbers within the landscape. So, finding it in 8 counties each year in Nebraska, 7 to 8 counties since its introduction, could be more of a reflection of our ability to locate it when it's in very low numbers. And a special thanks to the funding sources throughout this talk, which is the North Central Soybean Research Program, United Soybean Board, North Central IPM Center, and a number of others that have contributed, including the USDA. So how do we start the conversation on soybean gall midge? I thought a lot about this. I think the best way to do this is to start with, where does this thing come from each spring? So as we start our new production season, where does this insect show up? And so this is an image from March 2019 showing a couple things. You can see that I've put that image in of that damaged field that's on the far side. That's the injured field from the previous year, and you can see cages all throughout this image. So we went into 2019, we had a lot of questions. Where is this insect coming from each year? And so you can see we have them in last year's cornfield, last year's soybean field, as well as in the ditches in between, and even along the field border, because we wanted to be, to definitely understand where it was emerging from each season. And no statistics needed to understand where the insect came from. The image you see here shows pretty clearly. It's just a downward view on that now, as opposed to that image you saw before. And then again, there's that damaged field to show you what was last year's soybeans. You could see everything that we've collected for the last couple years from overwintering sites is coming from last year's soybean field. And so we've never detected spring emergence in last year's cornfield, which is a good sign if that continues to hold, because that means the insect can't overwinter for more than one winter. It seems to have to emerge each winter. So those fields that have injury, like the field you see here, that fall, they dropped off those plants and overwintered in the soil, and that's where they emerged from the following year. So let's start walking through the biology and ecology of this insect and gaining an understanding of how it develops as a problem. We're now aware that those cocoons originate with last year's damage, from last year's damaged soybean field. And that their distribution in the soil profile is also starting to be understood. And so here you can see an image, shows you soil cores. We took a number of these out of last year's soybean fields in the fall, and in case of 2021 in the spring. But you can see the distribution of those cocoons is up near the soil surface, within 1.5 inches of the soil surface. And so you may be sitting there thinking like, okay, is tillage an option? And we've certainly tried that. We're still exploring that. We're not seeing a lot of response from tillage, but they're up near that soil surface. And a number of a graduate student, Mika, who's currently working on the project, and Tinara Pasabam and Dr. Montesano were responsible for generating some of the data that you see here back in 2019. Okay, so let's move from where they are in the soil to how they emerge each spring. And so we're using these emergence cages, which you've seen in a couple slides now, in last year's soybean field to catch the adults as they emerge each spring. And so far, what we've been seeing over the last few years is that they tend to emerge in mid-June, with the exception of 2021, which is that last day in May. And this is pretty critical, because this starts the conversation around when we might want to try to manage this insect, as well as you're going to see its interaction with plant development stage of soybean. And if you're really interested in knowing those dates each year, when it emerges and where it emerges, you're welcome to join the soybeangallmidge.org. Go to soybeangallmidge.org and join our alert network. And so there's a little button there on the bottom, as you can see. If you click that button, you can join the network. And as a result, you'll get push notifications via text message or email or phone call, an automated phone call when it first emerges, as well as some management. Okay, so one of the most important things about the emergence of this insect is its duration of emergence, how long it emerges from that overwintering site. So the longer it emerges, the more challenging our scenario becomes for management. And so you can see here in 2019, we had about 15 days of emergence on average from overwintering sites. We finished that year and we thought, okay, as long as, if things stay in that range, it should be fairly easy, to time, maybe an insecticide or something else to control this insect. Unfortunately, and as you're going to see over the next few slides here, there's an ugly trend that shows up, which is longer and longer durations of emergence. There's 2020 at 25 days of emergence from overwintering sites. And then just this past season, looking at that emergence, up to 35 days. So if you're thinking about other insects and looking at the management of this insect, you can pretty much cancel the idea that any single tactic, especially chemical control tactic, is likely to provide complete control or sufficient control of this insect. And we'll need multiple things in our toolbox to manage this. Just to take a little bit of a different perspective on that emergence, here it is over time. So x-axis is June, July, August, and September, and y-axis is the soybean gall midge adults per day per cage from 14 sites. You can see most start to emerge around June 8th, but we do get those early emergers from a few sites, even that late May and early June. And so a lot of our emergence occurred the 6th, 8th, and then 12th and 13th in East Central Nebraska. We were done with emergence. So they emerge from those sites and they move to adjacent soybean fields. And this is just a representation of those adults coming out, moving across. We don't know how good of flyers they are. You're going to see some stuff in terms of distribution, but they move over to the nearest soybean fields, and then in that process, they start laying eggs into those soybeans. Now, the ability to lay eggs on a soybean plant is dependent, or their ability to infest the plant is dependent on the development stage of those soybeans. And this is a good graph, series of photos that show you that, which is nice clean stems on a V1 stage plant, no fissures or cracks present. And then those fissures or cracks starting to show up at the V2 stage. And the adults aren't piercing tissue as far as we know, but that female lays eggs just underneath that open fissure or crack. And then you can see the eggs and larvae that start to show up within those cracks over the next week or couple weeks. You can easily start to find larvae if it's a heavily infested area. And so just a little bit on scouting, since you now kind of have an understanding of how they get into a field and what that kind of looks like, is for most of you, those of you that have never seen this or not in high pressure areas where you see a lot of injury or damage each year, you can really wait till our 2-stage full flower soybean to start scouting all the way through R5, R6, which would be late, just prior to beginning maturity is a good time to scout. They're emerging from last year's soybean field. This is one of the easiest things when it comes to scouting is that they're in the first few rows is the best place to find them. And next to dense vegetation is the best place to look for them. Now you could see I changed that when to 7 to 10 days. If you're in a really high pressure area, that's a good time to start looking. You may start to pick them up within that time frame for where they are in the field. And in those areas with dense vegetation, you'd wonder, well, why dense vegetation? Why would that be important? Why would this insect be worse around those areas or more prevalent? It doesn't feed as an adult when they emerge, but they do need water. And so the current understanding is that maybe that water provides more opportunity for survival and thus infestation. Here's just a plant showing, that dark discoloration at the base. You could peel that tissue back. There's another plant here just further up from these two, and you'll notice it has a purple color. It's not infested. So it's this darkening, blackening, darker than normal that you want to look for on the field. One other thing to look for is sweet clover. This can be yellow or white. It can be along the field borders or edges of the field or in the ditches. And it's another host that we know for soybean gall midge, and they can be much higher on the plant on that particular host. So that's a good one to keep an eye open for. If you find them, send them to us. We can look at the genetics of them and make sure they're the same. Okay, so a little bit more detail now transitioning into a look within Nebraska in 2020 and what we've been seeing. So, we highlight all those counties and like, for instance, Gage County and other places. But you notice if you look across these two maps for average total larval number as well as injury score, we can find them in that county, and that's what the larval numbers show us, but the injury is quite low. So this varies each year, and we have 2021 data as well. But this insect where we find it in high numbers, we tend to have corresponding plant injury that matches that. And just to give you an idea on that score and scale, that 2 would be about 50% dead plants or wilting or dead plants in the field. And we're looking at a number of different factors. I'm just going to briefly highlight some of what we've found through this work with Rob Neatkar, who's also a master's student at the University of Nebraska. So some landscape factors that we've identified are obviously the percent of soybean planted in the area. That's a lot of insects are like that. The crop they're on, the more frequent that crop is, the more the population can go up. And then distance from dense vegetation. So, you know, you saw that issue and that reason to scout. That shows up in our survey too. As we look to how close our sampling is to where that dense vegetation is, injury tends to go up. Proximity to last year's soybean field, how close it is to that overwintering source. And then there are other factors that are a little harder to measure in a survey like this that I want to point out. And this is an evolving one, and so we'll briefly cover it just to highlight what you might want to look for. We have a simulated hail machine within my lab here at the University of Nebraska that's capable of shooting ice at about 170 miles an hour. It's a great stress reliever. It's used for a lot of things. Agronomics is the most important part of it. But Gall midge, when it came to us as what we thought was Gall midge back in 2011, these orange larvae that we were finding, they were finding them on these injured plants. And so this insect wasn't, if it was the same one, it certainly wasn't a pest back then. It was 2018 when it really built up as a problem. But we went back to that to say, does hail matter in the distribution of where this insect is on the plant, and the amount of injury that it could cause? And so that hail machine was used to injure a bunch of plots at different stages of development, as you saw. And the results were pretty convincing that this insect, it takes advantage of those additional injury points beyond just the fissures that you saw earlier. And here's an example of a plant injured by a hailstone, and you can see that dark discoloration around it. That underneath that is larvae. And if you took that stem and tilted it from the zeros up, anywhere we have injury on that plant, we tend to find larvae. A few exceptions here, but the larvae tend to be where we find those injury points on the plant. And so this is an area of considerable research coming up. And just to highlight a little bit more about that timing that you saw as part of how we set this up, you could see that early hail applications, you know, V1, V2, just a few trifoliates, aren't any different than no hail alone because the plant is quite small. But then if we wait till the reproductive stage is full flower, number of larvae per plant goes up. And so this is something I think if you get hail late in the season, you know, late July, early August, I keep an eye open for this in terms of the risk of these fields having a greater than normal abundance of larvae. So we're going to transition here from, you know, that discussion on where they are and what they look like. And this is just an array of symptoms to help you understand what you might see, which is this concave kind of depression of the stem, and the eventual wilting that takes about 21 days in most cases to start to show up under significant pressure. You know, from that scenario to an understanding of what happens to the remainder of the season after they're in these plants feeding and going through their life cycle. Then what are we looking at in terms of that year's soybean crop? And so this graph here that's coming up, this one that you can see now, shows that overwintering population that we were looking at earlier, and it also shows what's happening on this year's soybean field. And this is a combination of those 14 sites again. And you can see we get overlaps. You know, starting July 1st, we start getting adult emergence, and it continues really through the remainder of the season. And so, you know, once it's in that crop and starts emerging, we really see it for almost the remainder of the season. It's unusual over the last few years to even see a few dates when we wouldn't have adult emergence. So it's typically just present the whole season through to just about September. One thing I want to highlight for you, and a question we get a lot, is how quick are the generations on this insect? How many generations could we see in a season? And so we have an approximate way of estimating that. So from first emergence in last year's soybean field to then capturing them for the first time in this year's soybean field, that time frame, the distance between those, the time that it takes for each one of those events to happen, gives us a rough understanding with a lot of complicated factors in there that we'll learn about here over the next few slides on the number of days to the generation. What we've been seeing over the last few years and all the captures between those two fields is that it's about 27 to 29 days. And I realize that number might give you a lot of confidence because it's such a short, just 3-day window. And so to shake your confidence in ours, we've been seeing a range anywhere from 18 to 45 days. With that 45 days, looks like being related to more the stage of the development of the plants in the adjacent field and when they could get access. That 18 probably being a reflection of not capturing first adults because the cages aren't perfect and we should be well aware of that. Okay, so that 45-day mark, that's an interesting data point in terms of the distance. I want to briefly highlight what might be happening in that system by just quickly showing you a planting date study that looked at different planting dates in the system and the relative infestation. And so we had 5 planting dates that you could see there. We'll see them on the next graph here that you see now. On the very bottom of the slide, I know it's an empty slide, we're going to fill it. You could see that adult emergence occurred on June 5th. And so all those planting dates that you saw on the previous slide were out there. We came in at a number of points and sampled and determined if there was larval presence out there. And so we couldn't find any when we went out on June 18th. They were there, just a very low number. But when symptoms became apparent and it was easy to see them in the field, you can really see why that 45-day situation might happen. So first emergence here, but we don't actually have any infestation on these plants. They haven't even started feeding on those plants because remember that development stage, the fissure development occurred too late, for us to detect any at that point. And you could see the response for all those that are much further along in development. All these are in beginning flower, and then whereas this V4 stage plant just has had enough time that we could start to find them. Go ahead a little bit further, with continued adult emergence, we start to get infestation of that June 1 planting. And so that's why that 45-day scenario can occur is because they can't initially infest those plants until a little later. Okay, so back to our graph on this presence of adults. You will not be able to monitor adults like we can. We use those cages. We don't see them just by being in the field and looking for them. And so you're relying on that. But one thing you can see is larval numbers on these plants. You can't count and find them. And so I think this graph that you see now is hopefully useful in understanding what the population is doing through the season. So Vilma Montenegro, a master's student, was looking at population over the course of the season. And you could see just 6 days after first adult emergence, she started to detect larvae on plants. There's a lot of stuff in this graph. And so I'm going to put some bars over the top here that'll help you understand the average larval number over about a 2-week period. And you can see that first half into mid-July, 10 or so per plant, and then up to 30 to 40 per plant, or in the total over 3 plants, 98 to 100 or so, and then they start to drop off. So for scouting purposes, it's good to get out there, prior to getting to September time period, where by the tail end of September, we're down to about 3. You can barely detect them on plants. Okay, another key question we've got is how far do these things go in the field? And so now I want to kind of briefly touch on how far they can go. And so we did a study just this past year with plots going from the edge of the field all the way out to 500 feet, looking at larval number and plant injury and yield, because several of you in framing management wanted to know how far they would go. And so the graph you see here now is from June 28th. This is all the overwintering populations movement. And you can see that we can find them from the field edge, where we would expect to find them, and we could still find them at 500 feet. I don't want you to leave this graph thinking, oh man, we need to manage this insect to 500 feet. There's larval presence out there, but hang on, the story is more complicated than that. So about a month later, we sampled these again, and larval number as expected went up as they reproduced and continued to move within the field and infest. And you can see it's still very high along the field edge. And then things start to flatten out around 100 feet, but they are out at 500 feet into the field. What's a better understanding of what we're seeing in the field and the management zone that we may want to consider is injury score, how many dead and dying plants there are. The higher the number, the area under the severity progress value, the more injury there is in the field. And you can see injury photo from that, but you can see it's all stacked up in that first 100 feet or so near the edge of the field and it flattens out. And that value doesn't touch the x-axis because we can't find dead plants out there. They're just certainly not as frequent as what they are at the edge of the field. And then what everybody cares about is yield, which you can see here now on the graph. Yield from the edge of the field quite low, and then as we get out to that 100 feet, it starts to flatten out. This is the first year of a number of years that we'll do this project to better understand what is going on. And so I want to move to something of a little bit happier of a note, and to understand how important fissures are. Through the course of our survey, we were coming across scenarios where where a grower had used ridge tillage in his soybean field, and as a result had covered up the base of those soybean plants. We couldn't find any larvae in there, and so we were interested in whether or not that was a significant factor. And so just this past year, we did a hilling study. So I use the word hilling and not ridge tillage because we're not planting on a ridge. We're actually, covering the plants, pulling soil in and covering up those plants. And so the photos here are very compelling. I don't even really need to show you any data. You can see we covered those plants up just a few days after adult emergence. You can see what they look like when they're not covered. And you can see the photos showing, what is covered and uncovered and the amount of injury that can occur when those plants are not covered up. So to say, I know not a lot of people will use hilling, but that's how important those fissures are for infestation. And there's just a bit of data. Again, you don't need to look close at these graphs. The previous photos show it all, which is no hilling, had a lot of infestation, a lot of larvae present in those plants, and then the no-hill plants had a lot of presence, and then hilled had significantly less infestation in all three sites that we ran. And that infestation, that larval counting corresponded with plant injury, with greater injury in no-hill because they had access to those fissures, as well as a corresponding yield being greater in the hilling because, again, they couldn't infest those hilling treatments as frequently. Okay, I know a lot of you want to know about the acute practices for managing soybean gall midge, and they're ongoing, and obviously the challenge is that this insect has a long duration of emergence in a number of generations, probably at least 2 generations in this year's soybean field. And so we've seen some response, but it hasn't been consistent using seed treatments or foliar applications. We're trying a lot of things. We're testing several chemistries, but I would stress that we really want to look at this combined with a cultural control strategy. Something like even planting date is likely to be the best option amongst several other things. So you can see the photo here. This is a study that we ran on overhead as well as drop nozzle applications to compare those. And we're seeing some promise with drop nozzle related treatments. So just to summarize, a new species causing injury to soybeans, 5 states and 140 counties were challenged by the long duration of overwintering emergence and greater than expected movement, although I think we're still confined to our management within that first 100 feet. Fissures are really important for this insect's ability to infest the plant. The risk factors are evolving, like that hail, and our continued understanding of that as we move through. And then management is just going to be inherently difficult with this insect. And so with that, I'll take any questions if you have. My email and contact information there, and then again that website, which has got a lot of information as well as the funding sources.
Excellent, Justin, that was fantastic. There are a number of questions, and I can forward them to you just so you have them for future reference, but 2 I think are pertinent for the group at large, and one is questions about how distributed this organism is. How far east has it spread, and is it only in North America that we're seeing it?
Oh man, really important question. It is only in North America. It is only in the 5 states that I showed. So we are not aware of this insect in any other country except the United States. How far east is it moving? I understand that. There's the I states, right? We're in Iowa. Erin Hodgson is my counterpart in Iowa that's doing a lot of work on this insect, and she picks up just a few counties each year. And she's very good at looking for it. So time will tell. That big expansion or this number of counties found in Minnesota is intriguing. We had a derecho a few years ago that could have pushed this insect. When it's in very low numbers, it's really hard to find. So it's important that everybody's kind of looking for it. Not that we want to find it, but we certainly want to know it's there if it is.
Yeah, understandable. The second set of questions, I guess, is about those fissures and then also the plant tissue content. Are there data that correlate with the midge presence in the fields you see them in, and the tissue copper content, for example?
Oh man, excellent question. We have not dug into the nutritional side of the plant and its response to this insect. And we've gotten a number of questions on that. So I really don't have a good answer for you when it comes to, you know, the use of, say, a micronutrient, for example, and its response. We've tested fungicides and everything else, but not dug into that space. Those fissures are pretty ubiquitous, meaning that across a lot of varieties, or in our case, we've looked at accession lines of soybeans. We see it. Of the 716 that we looked at that represent a lot of diversity in the US, we saw fissures in every single of those accession lines. So soybean doesn't appear to have, you know, anything we've seen so far that wouldn't produce fissures because of stem expansion and cracking as a result of stem expansion.
All right, well, I think we need to wrap it up. Thank you again, and everyone on the, you can see his email and contact information on the screen. It will also be in the recording. I realize you can't click on it in this format. But Justin, thank you very much, and we look forward to seeing you all in 2 weeks. Thank you again.
Thank you for the opportunity.